At the peak of the Cold War in 1962, a Soviet spy was caught on American soil. Through numerous negotiations through years, the two parties agreed to a consensus that stated that the Russians had to solve three trigonometric problems within 15 minutes for the United States to release the espionage. It is a dark night in Moscow. The best of the mathematics professors at the Moscow State University were gathered together to save one of their best from a foreign prison. Here comes the first problem.
So here in Moscow, we have problem set number 3, and we're doing number 1, 2, and 6. So that's the prompt for first problem. And since it's already equal to 0 and factored, so we can write two equations based on that. There's zeros. I'll write that. I'll write the first equation in blue and the other equation in black. So that's continuous data minus row and that's 2 sine theta plus root theta equals 0. Let's just do some simple basic operations first. That's cotangent theta equals root 3, and since that's the easier one, so we just do that first. So that's based on the reciprocal identity. We know cotangent theta is equal to tangent theta 1 over tangent theta, which is equal to root 3, and we can cross multiply. Root 3 comes down to the denominator, and tangent just be alone. And that's 1 over 3, and to get the angle in radians, we need what? We need inverse. So tangent inverse 1 over 3 plus that. And based on that, we know we have unicircle, and in the unicircle we have it in pi over 6. Yes, we do. So theta equals pi over 6 plus m pi. M pi is for all solutions. Yeah. And pi over 6 is just, sine over cosine. And for this one, we do some simple operations first. Sine theta. Then we want the angle again. So that theta equals sine inverse root 3 over 2, and we have it on the unicircle again. And pay attention to the quadrant. It's the fourth quadrant. Since sine inverse's domain is bracket negative pi over 2 to pi over 2 bracket. So we have it in the fourth quadrant. So that's pi over 6. Okay, so we got the domain and stuff. So this is negative pi over 3, fourth quadrant, plus n2 pi. And the other solution we need is pi minus whatever sine inverse is. Okay, so that's 4 pi over 3 plus n2 pi. And yeah, that's it. That's it for the first problem. That's pi over 3. So all solution should be that pi and those. Let's do the same type of problem. By that I mean find all solutions type of problem. So here in Moscow, we choose number 6 on problem set number 3, which is find all solutions to tangent 2x equals 8. Let's write that down first. And and let's do it by 2 for the first step. Tangent 2x 4. A divided by 2 on the right hand side. Yeah. And that didn't involve any trig yet, so let's do some trig now. Shall we? Let's do tangent inverse to find the variable 2x. 2x equals tangent inverse 4. And we want x, right? So that should be, we should divide by 2. In the next step, well, let's calculate tangent inverse 4 for now. So make sure your calculator is in radian mode, and I got 2x equals 1.3258 plus m pi. For now, we add the m pi because all solutions. So I kept through four digits after decimal and rounded. So let's divide by 2 because we have 2x and we only want x. So we divide by 2 and that this part divided by 2, the constant is 0.6629. And don't forget, we need to divide that part by 2 too. By 2 too, huh? M pi over 2. So that's our final answer for number 6. Okay, here in Russia, we're choosing problem number 2 on problem set number 3. Okay, let's do this. Solve on the interval bracket 0, 2 pi parentheses, which means doesn't include 2 pi but includes 0. And it is cosine squared plus 1/2 equals sine squared theta. And first, we want the Pythagorean theorem. We want everything in the same sign. But yes. So it's quadratic now, basically. And we want everything to be the same trigonometric equation, and cos squared could be turned by the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1, and we can turn this into 1 minus sine squared theta minus sine squared theta plus 1/2, and we combine like terms like sine squared theta plus 2/3, and can be factored. Simple as that. And we want the quadratic formula, and we know what is the quadratic formula. Let's do it. And a equals -2, and we don't have a b, so 0, and c is 3/2. It's constant. And we do the quadratic formula. -0. Why? Okay. Minus 0 squared minus 2. So that's equal to sine theta, which is, yeah, basically x, right? So that's the -4 on the denominator. -0 is just 0, nothing, and plus or minus. Sine gotta be there, and that's not 0. That's not 0. For AC, right? That's 2, yeah. And 2 cancel out, that's 12. So we have two solutions basically, and let's erase this. And the left side we set it for the positive, and on the right side we do negative. They cancel out, right? I mean, by the way, root 12 could be simplified as you take out the 4, which is 2 on the outside, right, and then leaves you with the 3. So sine theta equals that negative cancel out, so 3, that's 2 root 3 over 4, and those cancel out. That's root 3 over 2, and they're same thing. So just different signs. So we could write sine theta equals that's root 3. Yeah, then we do the inverse. So let's do inverse here, because that would be probably that'll be that won't be the same. Okay, so this is, first quadrant. Okay, so that's pi over 3. Sine inverse. So sine inverse has the domain of bracket negative pi over 2 to pi over 2. So yeah, that's pi over 3 plus n2 pi, and pi minus that, which is the other solution. That's 2 pi over 3 plus n2 pi. And here we have, that's the fourth quadrant, right? Negative pi over 3 plus n2 pi, negative pi over 3. And we have still the same thing. That's pi minus, right? 4 pi over 3 plus n2 pi. So we want things between 0 to 2 pi, right? So that doesn't make sense then. That's extraneous. So basically x equals what we have here. Pi over 3, 2 pi over 3, 4 pi over 3, and most importantly, let's not forget coterminal angle. 5 pi over 3. Thanks, that's all. Since the Russians solved the 3 trigonometric problems under 15 minutes, the espionage was released. Yay, freedom!